Here we go. It just says section. Forget that. This is section 1, 2. I'm just not going to take the time to write that in there right now. All right. We want to draw a line. Oops. There we go. Draw a line like there. There's a nice pretty line. And we'll put an endpoint right here on that line. We'll put one down here like this. And we'll put one... Now, it kind of looks in the middle, but just because it looks like it's in the middle, does it mean it's in the middle? No, not necessarily. This example is right in the book. If you want to follow along, you can, or if you just want to write it down in your notes, you can do that as well. All right, so G. So there's line segment. There's a line segment EF, and there's a line segment FG, and what else is there? There's also a line segment what? EG. Okay, so if I just name the line segment, I would say EF. And then I would put it right there. So I say that's line segment EF. But if I talk about the length of the line segment, then I can say that EF equals, let's see, 2 3/4. They're using fractions here. So 2 3/4. All right. I don't put that little line segment over top of it. Why not? Because I'm describing the what? The length of it, right. So if I don't have a little line over top of it, it means the length of EF is 2 3/4. So if I want to, I can come over here and I can put it right on my little line. All right, and then it also says that FG is, oh, it also says 2 3/4. So guess what is true about F? It is right in the middle, right. Okay, it's right in the middle, isn't it? Okay, we'll talk about this at some other point, but we call that a midpoint. Okay, that's kind of getting ahead of ourselves, but we would call that a midpoint if it's right in between, exactly in between. All right, if it's halfway in between the two, these two segments are equal, we call that a midpoint. We'll talk about that at some other point, or some other time, I should say. All right, so what are they going to ask you? They could ask you, there's really not much they could ask you, basically one thing. What would they ask you? Yeah, what's the length of EG? So watch, if they put EG equals blank or question mark, I like to put a lot of times, they don't even have to write anything on there. They could say find, or they wouldn't even have to say find, would they? If they put EG equals question mark, you wouldn't even have to put the find there. What does that mean? It means find the length of it, all right? It's like, find it. Oh, there it is, like that thing up there. You ever see that? On the board, you know, find X. Oh, here it is. All right, so when it says, if it said find EG, you don't say, oh, here it is, right here. No, it says find the length of EG. I would mark it wrong on the test, yes. All right, if you just said here it is. All right, so what do we do with those two things? We just do what? We just add them up. So 2 3/4 plus 2 3/4. What is that? 2 and 2 is 4. That's what? 6/8 or 6/4, right? And what's 6/4? It's right. It's 1 and what? 2/4 or 1 1/2. So it's 5 1/2. All right. There you go. Look, I would rather you do this. I can't look over your shoulder when you go home to see if you. I can't look over your shoulder and see if you're using calculators or not. But I will harp a lot this year about using a calculator. Now, I have nothing against calculators at all. Okay, I use them quite a bit. But for something like this, your first instinct should not be to pull out a calculator and plug it into a calculator. Okay, I want you to learn how to work with fractions, and I want you to be able to do things. I mean, if I had like a 7-digit number times a 5-digit number, which we'll never have in geometry, but if I had something like that, do I expect you to do that by hand? Of course not. That's definitely a place where you use a calculator. Okay, or you had, you know, 0.0052 times 0.1348. I wouldn't do that by hand at all. That's when I would pull out a calculator. Something like this you can do by hand. Okay, and we'll talk about that quite a bit from time to time. All right, that was pretty easy. My goodness, that was almost too easy, wasn't it? Let's pause it. And let's make another line. We'll just make it nice and horizontal. Let's move this, if I can grab it. There it is. Just move it up here like this. And let's do this. Now we're going to do some algebra. We'll see how some algebra plays into this. The algebra's not hard at all. It's just setting it up. And this is probably the first time this year that we've done something like this, but it's not going to be the last. We're going to do this style, this whole style of thing right here. We're going to be basically doing this all year long. And I'll bring it up and I'll mention it to you quite a bit. That this is really the heart of geometry. It's taking a geometry principle, setting it up into an algebra equation, and then solving the algebra. That's basically what we're going to be doing all year. We'll be doing some other things as well, but that's a real big part of doing geometry. So let's see, they say that this is point X, and this is point Y, and this is Z. How about that? Okay, and now they say the length of XY is 3A. See how I put it right in between those 2 points? If 3A is between this point and this point, it means that's the length of line segment XY. Does that make sense? And then this is 14 right here. That's supposed to be a 4. Let me make that look a little bit better. Okay. Now, if that's all I had, would you be able to find what A is?
No.
No, you have no idea because you don't know the length of the whole thing, do you? But let's write it out. Let's say from here to here is my line's a little squiggly. It's not that. That's a little bit better. All right, let's say this is 5a minus 4. 5a minus 4. You follow me? That little line to that little line means the whole thing. All right. So there we go. We talked about a point being in between. Now this is not necessarily halfway in between, is it? But we don't know, do we? Here's something about geometry that is going to continue through the rest of the year too. Don't always make assumptions about a picture. If you look at this and you say, oh, Y is definitely not in the midpoint. It's definitely not the middle point of that thing. You can't just assume that. All right? Don't make any assumptions about where a point is located as far as if it's halfway in between or something like that. Does that make any sense? Because sometimes they'll purposely draw something that doesn't look right, but it will be in the middle or something like that. Yeah.
A equals 5.
Oh, okay. I don't want answers right now. We want to know how to do it. I don't care about the answer right now. Okay. I want to know what we do to this. Okay. Jameer?
5a minus 4 equals 3a plus 14.
Yeah, that's it. So you just take these two segments right here, 3a, and you take 14 and you add them up. So let's do that. So 3a plus 14 equals the whole thing. What's the whole thing? 5a minus 4. Okay. So I want to set it up first. And this is what we're going to do. On a problem, I don't want just an answer. That's why I don't want you just to say, okay, do it and give me an answer. I always want to work through these and make sure that we know how we got the answer. You follow me on this? So if you're going to do this on a homework problem, this is what you would need to set up. You don't really have to draw it out. If it's already drawn out for you in the book, you at least need to write this down, though. Everybody got that? All right, and then we're going to show our steps and get the answer. Let's go step by step. Don't just give me an answer, though. Okay, go step by step. All right, Tamir, what would you do first?
Plus 4.
Okay, you could add a 4 to both sides. Okay, right here. What else could you do in the same step?
Minus 4. Yeah, minus 3.
No, minus 5.
No, you do minus 3.
You could do either way. It doesn't make any difference.
If you do minus 5, I give you a negative.
Yeah, I'm kind of on your side on this one. I kind of like to keep them, but it doesn't matter. I could have subtracted a 5a, couldn't I? And then I've had it over here. It would have been a negative. It really wouldn't have been that big of a deal. But I kind of like to have the variables come out positive. Yeah, don't you? All right, so look what happened. That canceled out. What do we get here? 18. What do we get here? 2a, and that thing canceled out. Divide both sides by 2, and then a equals 9. Okay. All right, so if the question said, now watch, let me find out. It says find the value of a, so we did that. All right, but it also says find the value of xy. It says find what xy is equal to. Well, that's easy. What's xy equal to then? Okay, yeah, 3 times 9 is 27. There you go. And you could find the whole thing. You could do it. You could find the whole thing xz a couple ways, couldn't you? You could put that 9 back into this. 9 times 5 is? Talk to me. 9 times 5?
45.
Minus 4?
41.
Okay, or you could have done what? 27 plus 14, and you still get 41, wouldn't you? You with me on that? It's pretty easy stuff, isn't it? And that's basically, that right there is geometry in a nutshell right there. Okay, now we're going to be doing different topics. Every chapter we go to, we're going to be doing different topics. One chapter we'll talk about triangles. One chapter we'll talk about quadrilaterals. Some chapters we'll talk about circles. All these different shapes. But it basically boils down to this. We take a geometry principle. All right, we talked about betweenness. That was the principle we talked about adding the two segments equals the whole thing. So we take that principle and then we turn it into an algebra problem. Then we solve the algebra problem. All right, so it's not just geometry, is it? It's a combination. Algebra and geometry go together like this, okay? And that's what I want you to see. All right, Let's give you the assignments. Where's my book? Here it is. I wrote it down. So, section 1-2, we are doing, I'll write it right here, section 1-2, and you're going to do pages 18 and 19, numbers 10 to 32. I know it sounds like a lot. It's really not that much. That's what, 23 problems right there. Okay? That's not really that much. Alright, so there it is. So that's what you're going to put on your homework lesson, and that's your homework for tonight. Okay? Should be pretty simple. Make sure you show your work. Do you see all this stuff right here? If you had a problem like this, all that should be on your paper. Don't just write A equals 9. You got it? Alright? I want to see all the work. Now, there are some times where, like last night's lesson, was there really much work to show, if any? Except for the draw and the picture thing? No. Sometimes in geometry you can just write down an answer. But if you have some algebra and you got to solve a problem, I want to see all the work. I want to see the answer. We good with that? Alright. Alright, if you want to hear yourself on YouTube, everybody say bye. Bye.